Hi and welcome to the video on power rules. This video is designed to help you with future lesson on multiplying polynomials. Don't forget to have out your note page. We're not going to take notes in the beginning of the video, but we will shortly after, so just have it ready. Just to remind you all, power rules are the rules that you use when you're dealing with exponents, and specifically when you're performing operations on terms that have powers or exponents. Let's look at some examples so we know that these rules aren't coming from nowhere, they actually do make sense. If we take an example like addition, the one thing to keep in mind is that when you add or subtract, you have to be conscious of like terms. Like terms must have the same variable raised to the same exponent. So looking at this example here, we have 3p plus 4p. Let's say p's are representing pigs, and if you notice here, p, it does have an exponent. When there's no number written in for a power, we know that that is 1. So again, p's are our number of pigs here. And if we have 3 pigs and we add 4 pigs, we know we're going to get 7 pigs. What does that look like mathematically? You can break 3p down into p plus p plus p, and 4p down into 4 p's being added together. And if you count up the p's or you added up the p's, you would see that you have 7 p's or 7 pigs. And what's happening to our coefficients? Our coefficients in red here, 3 plus 4 gives us 7. So our coefficients are adding, which are following the operation that we're doing here. And then our exponents, remember the power here in these cases are 1. P is raised to the power of 1. Our exponent doesn't change. In our answer, we still have p to the 1. For a case like multiplication, we have to remember that, again, we do have to consider like terms, but like terms in this case, as long as it has the same variable, they are like terms, you can multiply them. So for multiplication, if we have something like 5x to the 4th power times 6x to the 7th, let's see what happens. We can break these two terms down again. And in this case, for multiplication, when you break it down, it's called factoring. So we can factor those. And notice we have 5 times x times x times x times x, and this becomes 6 times x times x times x times x times x times x times x. And in our answer, what we get is 30x to the 11th. Well, let's see where we got that. Obviously, the 30 comes from the fact that since everything is being multiplied here, 5 times 6, they're going to multiply to give us 30. And we have 4 plus 7x's being multiplied by itself, right? So when we represent that in power notation, since there are 11 x's all being multiplied together, that becomes x to the 11th power. And if we take a look back at what we started off with, our coefficients, 5 and 6, they multiplied, which was following the operation, and our exponents, 4 and 7, they added. One more example with multiplication. This time we're going to throw in another variable here, y, just so you can see that what it looks like when dealing with like terms with multiplication. So the rest of it, 5x to the 4th times y, 6x to the 7th times y squared, what do we get? Again, let's factor this out or break these terms down a bit. And if you notice, again, we have 5 times x times x times x times x times y. And then 6 times all these x's times y times y. All right, what's our answer here? Our answer here in this case is 30x 11th y cubed. So how do we get that? Notice what's happening with our coefficients. Again, they're multiplying just as we say. 5 times 6 gives us 30. And then x to the 4th times x to the 7th, those exponents or those powers there add. 4 plus 7 will give us the 11. The exponents for y also add, so this is y to the 1st power since there's no number written there. 1 plus 2 will give us y to the 3rd power. And again, it all makes sense because we have 1, 2, 3 y's being multiplied together, and then a total of 11 x's being multiplied together. And in power notation, that's what that looks like. All right. Now, are you planning on doing this each and every time when you're dealing with powers? Probably not, right? It's a lot of work here. So it's your job to memorize them, and you can do that by making flashcards from the notes that we're going to take in a moment. And another scheme I like to use is this, what's called an operations pyramid. So go ahead and label that in your notes as an operations pyramid. And now let's consider what are the key takeaways. So you don't want to memorize all of these things. You kind of want to memorize a few key takeaways. All right. First key takeaway is that coefficients, which are the big number in front of the variable, they always do exactly what you say you're going to do. Always. If you're adding, they're going to add. If you're subtracting, they're going to subtract. If you are raising them to a power, they are going to be raised to that power. Exponents, on the other hand, if you're using this operations pyramid, they're going to do a lower operation. Okay? And exponents are small numbers in the back. They do the lower operation. And what do I mean by lower operation? This pyramid kind of arranges the operations in a way in which as you go up the pyramid, the operation complexity increases. So think about that. Nothing is the easiest or the most basic operation, doing nothing, right? And then as you go up, you do addition and subtraction. You learn that first for a reason because it's the easiest operation that you can think of, right? And then as you go up to multiplication and division, which is kind of easy, but not as easy as addition and subtraction. And then finally, powers and roots. So the complexity goes up along the pyramid. So how can we use this? As I said, key thing to remember, coefficients do what you say you're going to do. So let's look at the addition example. We have the coefficient here in these two terms, 7 and 4. We are adding them. Look at our coefficient. It adds. So whatever your operation is, the coefficient follows that operation. It does exactly what you say. But the exponents, on the other hand, if we're using the pyramid, they're going to do one level below. So if you look under the addition symbol, it's nothing. So the exponents do nothing. That means they stay the same or we keep them. Same thing with subtraction. We have another example here. 7 minus 4 will give us 3. Our coefficients are subtracting just as we say we're going to do. And the exponents are the powers. They're going to do nothing because that's one level below. So coefficients do what you say and exponents do one level below according to the pyramid. Next we have the example of multiplying and dividing. So if we're dealing with what's called product of power rules, product is the answer to a multiplication. Our coefficients here are 3 and 4. If we're multiplying, they're going to multiply. 3 times 4 will give us 12. And underneath multiplication in our pyramid is addition, right? The operation underneath that. So if our coefficients are multiplying, if we're performing multiplication, our exponents are going to add. Look at our exponents here. We have x to the second power and x to the seventh power. So 2 plus 7 will give us 9. So we get x to the 9. Similarly, we have the same thing happening here with division. Our coefficients, if we're dividing 20 x to the 10th divided by 5x to the third, 20 will get divided by 5. Coefficients follow the operation. And then our exponents, 10, will be subtracted by 3, which will give us the exponent of 7. So we get 4x to the 7th power. Last but not least, similar thing happens, or the same thing happens with powers. We are raising 3x to the 5th. We're squaring it, so we're raising that to the second power. Our coefficient 3 will get squared. So 3 times 3, or 3 squared, is 9. And look at the exponents. 5 times 2 will give us 10. So the exponents multiply. Now, does that fit what we're seeing in the pyramid? Absolutely. If we're raising something to a power, the coefficients will raise that power, and our exponents will multiply. And with roots, it's just the inverse operations there. So with roots, if we are taking a cube root, in this example, of 125 times x to the 6th, the coefficient, we will take the cube root of that. Cube root of 125 is 5, and we will divide the powers, because underneath roots is division. We divide the power, so 6 will be divided by 3, which will give us a power of 2. Alright, pause the video as necessary to copy down all the information on this page. I will be checking that this information is there. It's not too much to copy. And as I said, it's your responsibility to memorize this, so you may do this through flashcards or using this operation pyramid if you find this helpful. Don't forget to do your Delta Math practice, And I hope you have a quality weekend. I'll see you soon.